Now, whenever you're actually about to solve a physics problem, you're going to need to convert all of your units back to base units. Technically, as long as your units match, it doesn't matter. So an example of units that match up, if you have a velocity that is in kilometers per hour, right? You have a time that is in hours, and you're looking for displacement. You can expect that displacement to come out in kilometers. Notice how all the units match: kilometers per hour, hours, kilometers. But it's a lot easier just to go ahead and always convert back to base units. It's one way to guarantee that you're going to be able to get everything right. Base units for physics: distance is meters, and that's the standard SI base unit. For mass, it is kilograms. Now, there is a little bit of discrepancy here. In physics, we use kilograms as our base units. In chemistry, they use grams as their base unit. Now, think about why that is. In physics, we're dealing with large objects in a world, sometimes incredibly small objects if we're in quantum, but for the most part in Newtonian physics, we are looking at large objects, easier to measure people and cars and desks and things like that in kilograms. In chemistry, if you actually used kilograms of reactants in an equation, in a chemical reaction, you could get some pretty bad results. So you don't want to actually use kilograms. They use grams. We use kilograms, though, as our base unit. Base unit for time is seconds. So you'll have to be able to convert from hours and minutes back down. Now, you probably have, at least I hope you have, learned how to convert metrics by jumping the decimal, and I'm going to post a worksheet over that to try to help you with it, because there are circumstances where you need to do that. And chemistry will teach you an even better way with dimensional analysis, but because that's going to be used in other parts of chemistry also, and I might even delve into it a little bit this year. But I want to teach you a short way to convert always back to base units for most things, time and mass being excluded, but all the others with newtons, all the other base units, this works, specifically using the prefixes in scientific notation. These prefixes will be given to you. They're given to you for an IB physics exam. They're given to you for the AP physics exam. Thus, they will be given to you in my class. So you simply use the prefixes. If you see a prefix of mega, you drop the mega and replace it with times 10 to the 6th. Mega means times 10 to the 6th, or million. Kilo means times 10 to the 3rd, or 1,000. Centi means times 10 to the negative 2nd. Jump it twice, making it into a smaller number, right? Milli, negative 3rd. Micro, negative 6. Teeny tiny, nano, negative 9th. We didn't get into angstroms and picometers. We can talk about that later. So now let me use this prefix idea over here on distances to show you what I mean. 2.5 kilometers is the exact same thing as 2.5 times 10 to the kilo means third meters. Notice all that I did here. I dropped the prefix kilo and I put on what kilo means, times 10 to the 3rd. 32 centimeters. Well, that's the same thing as 32 times 10 to the negative 2nd meters. Now, pause. This is not proper scientific notation. 32 times 10 to the negative 2nd meters. This should say 3.2. right, times 10 to the negative 1st meters. But I put it in improper scientific notation. Why? Well, because whenever you are actually doing your algebra and punching this into your calculator doesn't care if it's an improper scientific notation. So you can punch in improper scientific notation, convert with this simple idea of all you had to do was look at the prefix and then put on what it means in scientific notation over here, times 10 to the negative 2nd, and use that to do the algebra. And then your calculator will give you out the correct answer whenever you've done all your math in proper scientific notation. So understand, just because right now I'm showing you it's okay to convert in improper scientific notation does not mean it's okay to report your final answers in incorrect scientific notation. You would want to put it in the correct notation there. 750 nanometers. Same thing as 750 times 10 to the negative 9th meters, because nano means times 10 to the negative 9th. And 32 megameters is the same thing as 32 times 10 times 10 to the 6th meters. Now, when converting mass, you actually do have to jump the decimal, and the most common thing that you're going to have to convert between is grams to kilograms. That's the number one conversion that's going to end up having to happen. And so the thing to remember is there are 1,000 grams in a kilogram, and that a kilogram is much larger than a gram. So if I have 32 grams, that should become some decimal number of kilograms, and 1,000 has 3 zeros in it, so I'm going to jump the decimal 3 times to the left and end up with 0.032 kilograms. 2,500 grams, jumping the decimal 3 times to the left, leaves me 2.5 kilograms. Now, time is a little bit different because time is not base 10. In fact, things change, right? For example, there are 24 hours in a day. There are 60 minutes in an hour and 60 seconds in a minute. So if I need to convert 3 minutes down to seconds, you say, okay, how many seconds are there in a minute? The answer is 60, and so I'm going to set it up. So I set up 60 seconds over 1 minute. That's the conversion factor. By the way, this actually is what I'm showing right now, the basis of dimensional analysis. But basically, 3 minutes, there are 60 seconds per minute, so 3 times 60. And of course, that we come out 180 seconds there. What about 2.5 minutes? That's the exact same thing. 2.5 minutes times there are 60 seconds, and this is, I need to put in my unit there, 60 seconds per 1 minute was messing up there. Notice how the minutes cancels out, 1 in the numerator, 1 in the denominator, so 2.5 times 60. This is 150 seconds, 3.2 hours. Now I'm going to have to actually go through a few extras. First off, how many minutes in an hour? So I have to converting down 3.2 hours. Well, there are 60 minutes in 1 hour. So then I multiply, and I come out with 192 minutes, but I'm not done here yet. I've got to get from minutes down to seconds. So 192 minutes, sorry for running out of space here, times there are 60 seconds per minute. So whenever I multiply there, I come out with this 3.2 hours has 11,520 seconds in it as the answer. Now let's look at one that's mixed, 2 hours and 32 minutes. First thing to do is to get my 2 hours down to minutes. So in 2 hours, 60 minutes per hour. So as we all know, 120 minutes there. But I have 2 hours and 32 minutes. That's the 2 hour portion. So add on my 32 minutes, 152 minutes, and now let's convert that to seconds. And now I come out with 9,120 seconds here. Not worrying about sig figs necessarily in these conversions ideas, just trying to get the idea for how the problems are, or for what you need to do to convert. So whenever you have a standardized, if you will, sort of unit, for example, distance, you just look at your prefixes, right, and convert using your prefixes. Kilo means times 10 to the third. Centi means times 10 to the second. So I just put on the meaning of the prefixes. Mass is a little bit different. You need to remember 1,000 grams goes into a kilogram. And so if I'm converting from grams to kilograms, jump the decimal 3 times to the left. Time is even more different than that. You need to remember how many hours there are in a day, 24 hours in a day. Maybe we're even in years, 365, technically 365.25 or whatever it is, days in a year. You need to remember how many hours, minutes in an hour, how many seconds in a minute, and then be able to convert all the way down to seconds.